Dear students, from this slide we are going to discuss about the subject of antenna design. The subject code is CEC 335. So now we are going to discuss about the unit 1. So the first we are going to discuss about the antenna array fundamentals. So here the first thing we are going to discuss about linear arrays. So linear antenna arrays form the foundation of modern wireless system for 5G networks to advanced radar. So this presentation we are going to explore how multiple antenna elements working together create radiation pattern that enables today's communication infrastructure. So that modern 5G networks we have these types of linear arrays. So you can see through this picture also. The next thing we are going to discuss about what is linear antenna array. A linear antenna array consists of multiple antenna elements arranged in straight line along a single axis. So this configuration is fundamental to modern RF engineering, offering significant advantages over single element antennas. So, by carefully controlling the spacing between the elements and the spatial relationship of their excitation signals, engineers can shape the radiation pattern to meet specific design requirements. So, this array effectively synthesizes the larger aperture, concentrating radiating energy in the desired direction. So, through this linear array, we have the three important features. The first thing is we can improve the gain. So how we can improve the gain is multiple elements combines to increase overall antenna gain, extending the communication range. And the second feature is enhanced directivity. Concentrated radiation pattern, reduce interference and improve the signal quality. So by improving the directivity in our linear arrays, we can enhance and we can make the radiation pattern properly. By that we are improving the signal quality. The next third feature is pattern control. So by maintaining spacing and the space relationships, it determines the beam shape and the direction. So these are the three main features involving in the linear antenna array. So here you can see here I am showing the picture of that patch antennas. How we can make the space and the phase relationship among the patch antennas. So these are the one simplest view of linear antenna array. So always remember that the linear antenna array, what you have to do, that multiple antenna elements arranged in the straight line along the single axis. So now you can see here the picture that multiple patch antennas are arranged in the straight line axis. The next thing is we are going to discuss the types of linear array. That means the configuration of linear array. We can keep multiple element in the linear array. So the first thing, the basic linear array, that is two element linear array. So in the two element linear array represents the simple configuration and understanding the array behavior. It provides the fundamental building blocks of more complex system while demonstrating key principle of constructive and destructive interference. So in that we can keep it the three things. The first thing is that element spacing. So the first radiating element with the reference space and the spacing D have to make the critical parameter determine the interference pattern. And the third thing is element A2. So here you have to mind that second element with the control phase offset. So here this geometric arrangements creates the path length differences to observation points, so resulting in the phase variation that constructively or destructively combining the radiative pattern. So this interference patterns forms the basis of array directionality. So in that you can see here that the two antenna elements are there. That modern antennas only I am given the example here. So here we are keeping the two element linear array. So in that you have to keep the two parameter, that element A1 and A2, and the spacing, see here the two element, the spacing we are keeping here. So this is two element linear array. So in that the two element linear array, we need to keep it that key characteristics. The first thing is fundamental configuration. So in that fundamental configuration, the two element array shows the simplest building block for understanding how multiple radiating elements interact to form the directional patterns. And the second thing is array factor. So in that you have to remember this formula. 2 cos pi by 2, it describes the normalized field pattern which that psi represents the total phase difference. So the third thing is we need to remember that beam formation. So in that you have to remember, by analyzing two element behavior, engineers develop the intention for controlling beam direction with side lobes in the larger arrays. So in that, see here, the two element space linear array, you need to understand the phase difference. So here we are combining the phasal space and the total phase, that equation will be, see here, that psi is equal to BD cos theta plus psi. So here that beta is the wave number and D is the spacing and theta is the observation angle. And the next thing is we are going to discuss about how the two element array, it will be creating the nulls you and maxima in the radiation pattern. So this is the fundamental scales directly to the n element configuration. So see here, here you have to remember that the three things: fundamental configuration, array factor, and that beam formation, and finally that we need to remember the phase difference of the equation psi is equal to beta d plus beta d cos theta plus psi. So thank you.